This talk is for engineers who already know image generation but still want a cleaner mental model of ComfyUI. I want to make the internals feel concrete, not magical. We will walk through the server, the queue, the execution engine, the node system, and the local file model by the end. You should know where ComfyUI helps a real app and where it does not. Most people meet ComfyUI through the canvas, but the canvas is just the front door. Underneath ComfyUI is a local runtime that reads workflow, JSON, validates it, runs nodes in dependency order, caches useful work, and saves outputs. Once you see it that way, the architecture stops feeling mysterious and starts feeling like something you can integrate on purpose. If you want a fast way to learn ComfyUI, start with 5 files. Main.py starts the app, server.py owns the API and WebSocket events. Execution.py runs the graph. Nodes.py loads the registry. The folder paths file decides where models and outputs live. Once you know those files, the whole repo becomes easier to reason about. PromptServer is the runtime edge. It accepts work, puts it on the queue, and streams status back to clients. That is why ComfyUI fits real products. Your app can submit a workflow, watch progress, and fetch results later. You do not have to drive everything through the GUI. The good news is that the API surface is small in practice. Most apps only need the prompt endpoint, the queue, the history view, and the WebSocket updates that gives you a clean boundary. Your app can keep auth, approvals, and product logic. ComfyUI can stay focused on running media workflows. Now, we get to the real contract, workflow JSON. Every node has an ID, a class type, and an inputs map. Links are explicit. That means workflows are easy to inspect, diff, template, and generate from code. So the goal is not to draw graphs by hand forever. The goal is to create stable workflow templates your app can fill in safely. One design choice I really like is that validation happens before execution. If the graph is malformed, a node is missing, or inputs do not line up, ComfyUI fails early. That is great for application builders. You can catch bad requests before GPU work starts and return a normal error instead of a mystery crash. Once a workflow passes validation, execution becomes a graph problem. ComfyUI resolves dependencies, pulls outputs from upstream nodes, and runs only what the current graph needs. That is why this model fits media pipelines so well. These workflows have reusable branches, expensive setup steps, and very clear data flow. One big practical win is cache reuse. The runtime tracks what changed and reuses work when it can. If you change the prompt but keep the same model and preprocessors, you do not want a full rebuild. That speeds up local iteration. It also makes ComfyUI feel like a useful runtime instead of a blind batch script. Now, if the engine is the core, nodes are the extension surface. Built-in nodes come from the main repo. Custom nodes come from the custom nodes folders. The runtime only cares that a node is registered and exposes a valid input and output contract. That is exactly where product-specific media logic should live. Another practical detail is the file model. The runtime has explicit places for models, inputs, outputs, and user data. The folder path rules make that a real contract. For a local app, that matters a lot. Clear file rules make model discovery, asset management, and debugging much easier. Now, switch from internals to integration. The queue keeps your app simple. Submit a workflow, get a prompt ID, then choose how to watch it. A command line tool can poll, a web app can listen on the WebSocket, or a background job can check history later while ComfyUI does the GPU work. Once you start integrating ComfyUI, treat workflows like source code, not like fragile canvas state. Keep them in Git. Decide which inputs are fixed and which are parameters. Map product terms like prompt, seed, or size to specific node IDs. Then log what you ran. That gives you reproducibility and makes the system easier for teammates to understand. If you keep repeating the same cluster of steps, that usually means you should write a custom node. It gives you a stable interface and keeps the graph readable. Instead of asking the rest of your app to know 10 low-level operations, you give it one higher-level tool with a clear contract. When something breaks, artifacts are what save you. Keep the submitted workflow, the run ID, the node versions, the model choices, and the outputs. Then debugging becomes normal engineering work. You can compare runs, reproduce failures, and see what actually changed. Without that trail, the runtime can feel opaque. On a strong local GPU machine, ComfyUI becomes much more attractive. The round trip is short and the hardware is close to the app, but that also means environment drift becomes real. Different nodes want different packages. Different model families want different torch behavior. So treat these workflows like infrastructure with health checks, isolation, and repeatable builds. If you want to apply this in your own repo, start small. Pick one media task that matters. Build one stable workflow, put one adapter in front of it, then log every run like a build artifact. Once that path is reliable, expand from there. So, the main takeaway is simple Comfy. UI works best as a local workflow runtime for media generation. Workflow JSON is the contract. The queue and history make it usable from code. The node system makes it extensible. And the file model makes it manageable on disk. Keep your application logic outside the graph, and ComfyUI becomes a strong building block instead of a messy center of gravity.